Okay, today we're going to start section 0.1. It will take us a couple days to get through the whole section, I think. We're not doing the whole section today. We're going to start with solving for variables. And then we're going to move on to solving for variables that have fractions in them, which is a skill that you haven't really done, but it makes quite a bit of sense. So let's start with something easy. 4x plus 8 equals 12. Why do we subtract the 8 first?
Order of operations.
Good. A lot of people say you need to subtract the 8 because it's not attached to the x. It is attached to the x through addition. But the 4 is attached to the x by multiplication. So if we look at the order of operations, there are two operations. There's a multiplication, and then there's an addition. Which operation hits the x first? The multiplication. So this would be operation number 1. And then the addition would be operation number 2. And you guys know that, please excuse my dear Aunt Sally, I like this one better. Pedal. So parentheses, exponents, and this is actually division and multiplication. The reason I don't like, please excuse my dear Aunt Sally, is it makes multiplication look more important than division, and it's not. They're equal. And then this would be addition and subtraction, and then the L would be later? No. Left to right. Left to right. Right? So if you have multiple additions, which one do you do first? The one on the left. Does it really matter? No, but if everybody goes left from right, then we'll have the same sort of solutions. We'll all get the same answer. So the nice thing about pedal is, if you order this according to pedal, how do you solve for x? Yes, this is cheesy.
Pedal. Wait, why? Oh my goodness, we're missing Darian.
We are. She's in the other class. So, if you want to solve an equation, you look at the pedal, and then to solve for x, you just pedal backwards. So instead of starting at the top and working your way down, you start at your bottom and work your way up. You don't really need to worry about left to right. So we undo any addition and subtraction first. How do you undo plus 8? Subtract 8. Why? What does that do? It equals 0 and it cancels. Now, in addition, what number is nothing? 0. So the idea is to use the inverse of positive 8, which is negative 8. Positive 8 and negative 8 cancel, which means they turn into what's called the identity, which is nothing, which is 0. So I subtract 8 over there, and now I have 4x equals 4. Okay, this turns into nothing. How do I undo a multiply by 4? Divide by 4, and it turns into nothing, which is 1. So the addition nothing is 0. The multiply nothing is 1. And that's the idea. Those are called identities. Okay? And then we divide this by 4, and I get x equals 1. What does that number mean? That is the only x value that will satisfy the original equation. So how do you see if you're correct? Well, you get rid of all of this stuff. And then you plug that back in and you stick it right here. What is 4 times 1 plus 8? 12. Now, some equations will have multiple solutions. What do we call it when an equation has two solutions? What kind of equation has two solutions? A quadratic equation. An x squared equation will have two solutions. An x to the third will have 3. Or they might not have any. Right? What if I had 4x plus 1 equals 4 x minus 3. That can't happen, right? It will never happen. Because something plus 1 is equal to the same something minus 3. So what we're saying is 1 equals negative 3. That has no solution. Okay? Some equations have infinite solutions, like 3x equals 3x. What's the right answer? Any number you can think of. 7 will work. Negative 8.3 will work. That has an infinite number of solutions. Okay? So, let's make this a little bit more complicated. 2x plus, 2 times x plus 4 minus 6 equals...
2x plus 8 minus 6.
So we have two options here. We could either distribute the 2 and then simplify and then move everything over, or we could just work with the order of operations. What operation is first? So we look at the x. What hits the x first? Nope. The 4. So this would be 1, this would be 2, and this would be 3. So Jimmy, when we pedal backwards, so we undo 3, which is a plus 6. Plus 6 equals 16. There we go. And then divide by 2. So x plus 4 equals 8. And we subtract 4. And I get x equals 4. Okay? So you guys have sort of been trained to always distribute a leading coefficient in front of a parenthesis. In this class, you don't necessarily want to do that, because a lot of times having it out front will be easier to use than multiplying it in. And we'll see more problems kind of like that in the future. Look on page... page 6, example 2. So it says 5x minus 7x minus 4 minus 2 equals 5 minus 3x plus 2. How do we solve for x there? Okay, we need to get all of the variables together. What would your first step be? We could. So we could either move this constant over here, move this constant over there. It doesn't matter. So we could do that. So now I have a negative 7. What else? Well, I kind of have a problem in those parentheses. Well, it won't matter. We need to distribute the negatives. We need to distribute this in and distribute this in. And I told you that you don't always want to do that, but in this case, you have to. So, 5x. How do you distribute a negative? You just change the sign, or multiply by negative 1. So minus 7x plus 4 minus 7, let's get rid of that, equals negative 3x minus 2. Now what should I do? So combine like terms. Let's move all the variables to the left and all the constants to the right. So 5 and 3 is 8 minus 7 is 1x. And I'm going to subtract 4 and add 7.
X equals 1.
So it should be positive 1, right? Now, if it's a simple solve, an algebraic solve problem, you should never get the wrong answer, because you can always plug it back in and check. So this would be, plug 1 in there, I get 5 minus... That would be 7 minus 4 is 3, but it's a negative, so it's negative 3 minus 2 equals 5 minus 5. And I get 5 minus 3 minus 2 is 0, and 5 minus 5 is 0. Does 0 equal 0? Yes. So I either did it right or I made 2 mistakes that worked themselves out. Any questions there? Now, what if there are fractions? Like example 3. 1/2 p minus 5 times 3/4 or equals 3/4 p. Why 4? Okay. So why did she pick 4? It's the common denominator. It's the least common multiple of the denominators. So if I multiply by 2, will it simplify the equation a little bit? A little bit, yeah. If I multiply by 4, then 4 over 2 will simplify to be a whole number, and 4 over 4 will also simplify to be a whole number. So I'm multiplying everything by 4. And then I get 4 times 1/2 is really just 2. So 2p minus 4 times 5 is 20 equals 4 times 3/4. You can look at it as 12 over 4, or what is 4 times 3 over 4? It's just 3. Okay? So 3p. Now what? Subtract the 2p. Negative 20 equals p. And that's actually the answer. Okay? So that's example 3. Okay, look at your problem set on page 15. On number 27, what would you multiply by? On number 27, 60. Okay, what about on number 32, what would you multiply by? Why 10? So the question we're asking is, do 2, 5, and 10 all go into 10? Yes. Okay, what about 37? Multiply by 6. What if I had, and it doesn't look like you're going to have to worry about this, but what if I had a 6 and a 5 and a 10? The least common multiple is 30. What if I mess up and multiply it by 60? It still is going to work. You'll just end up with bigger coefficients, and in the end, you're going to end up with a fraction that needs to be simplified. But as long as you pick a common multiple, you will get the right answer, provided you do everything else correct. It doesn't have to be the least common multiple. It just makes it easier if it is the least common multiple. So your assignment for this set is 1 through 38 all. And the odd answers are in the back of the book. I recommend that you come get a sticky note or something and put a bookmark in the end so that you can flip back and forth and make sure you're getting the correct answers. All right. Good luck.